Prove by contradiction that if 3a plus 9b is equal to 1, then not both of a and b are integers. So we start by supposing the negation, which is suppose that if 3a plus 9b equals 1, then both a and b are integers. So we're going to suppose that. So that means that 3a plus 9b is equal to 1. Doing a little bit of rearranging, we can get this to be 3a equals 1 minus 9b, which means that a is equal to 1/3 minus 3b. But this is a contradiction, because if a and b are both integers, then we have an integer on the left-hand side, but on the right-hand side we have 1/3 minus an integer. And we know that the sum of a non-integer and an integer cannot be an integer. So 1/3 minus 3b is not an integer if b is an integer. So this is a contradiction, because we have reached the conclusion that an integer is equal to a non-integer. So that doesn't make sense. So we've got a contradiction. So the only thing that can be true is that the original thing was not true. Which means that one of them, at least, is not an integer.